So we kind of left off on this idea of public, private IP addresses, and I talked about those class A, B, and C addresses. And we figured out, holy cow, there's really only 2 million IP addresses out there, and that's not enough for everything we want to do, right? And so one of the crazy things we need to talk about in here is this dividing line between the network, that's what you're given, and the piece you control, which is over here. And so at your own house, how many of you have a router, of those people in here? You have some kind of wireless router in your house? You have more than one person connected to the internet? Yeah, almost everybody does, right? Because nobody hooks up to a phone cable and they're actually plugged in with one computer anymore at their house, right? At your house, those routers set you up with a Class C address internally. Almost always they say, well, here's a Class C, and if you look, does anybody know the IP address to their own router? Have you went through that before? Oh. So there's a couple of addresses they use really, really commonly. I'm going to slide over a tab, and I'm going to actually show you the router we use here in our lab. So 192.168.1.1 is probably the most common, or 1.0. Well, we have a little different addressing scheme because I wanted to make sure ours was different than anything else on the college campus. Because our little campus in here, we're a little bit unique. Yes, I do really want to proceed. Go. All right, so if I can remember the login name, always handy. And so one of the security tips I'm going to give you, if you haven't went in and changed your user account on there, so it says administrator or Linksys or default or whatever, if you haven't changed that, the default name and password, how many people out there are able to get access to that router? Anybody who goes online and says, what's the default address for Belkin or D-Link or Linksys? Or, yeah. So quick tip of the day, make sure you've changed that. So this is actually the router we have that runs this lab. And so if I look at it, that doesn't look very exciting. And it says there's my outside address right there. So my internet comes in, and it's a 10.20.208.1. I have another address, 192.168.2.1, that's used for another purpose, but I temporarily have it disconnected. And our lab sits at 192.168.180.1. All right, so we didn't do like CSI. We didn't screw up. All of those are within range. That 192.168.1.1 is what almost all of your routers are going to be on. If I don't know what that router is there an easy way to find it out of the tools we've already used in here? Yeah, there is. Remember that config, IP config? So if I do an IP config, it's going to show me IP, I got to do a CMD first, would be helpful. So CMD, and remember our buddy, this black box, we do a IP config, if I can get it moved over, drag. And notice it's going to point to something called a gateway. Come on. All right, so if I do this, it's going to point up here to something called a gateway. Go, there it goes, IP config. All right, so notice it's going to tell me I have a default gateway of 192.168.180.1. That's my router. If you don't know what your router is, and you go, oh, I should probably change that default password at some point, this is a way you can find that out. And so when I walk into somebody's business or something else and they want some help, I do an IP config and I say, well, let me see your router first. Now, some routers, so if you have EDI Max or some of the TP-Link stuff, may do something weird. It may be a 2.1 or 10.1. So this is a quick way that I can figure out what I'm doing there. So right now, everything in this lab, so my computer, your computer, everybody's computer is all going through this particular device right here. So what I'd like all of you guys in here to do for me real quick is open up another tab and go to a YouTube video. And I want to see if we can spike the traffic up, just to see if we can. So, go grab a YouTube video, start playing it. Doesn't matter what it is. And we can start to see that traffic increase. So notice, oh, I can tell where you guys started getting traffic. And so just on that alone. So one of these shows me in, one shows me out. So this is my transmit out back to you guys. This is my input back in. Those are the two connections I'm using, ETH1 and ETH0. So at this particular time, it looks like I'm about 600 kilobytes or almost a gig in and almost a gig out of this device. So we're hammering it pretty good. I can also do some other fun things in here. I can look at the traffic and I can actually see where you guys are going and which computer. So from your IP config, you should be able to tell me which computer is 180.83 because you've used up more bandwidth than anybody else in the lab. Weirdly, I know that my teacher station is the 101, so one of you guys is using a lot of bandwidth. And notice it's changing there dynamically. So I can actually see the top people in here, and so you could tell me which one is yours. So 1 to 10 of 35 entries. And it's got some routing pieces, and we're going to talk about that again. But we'll play with this guy a little more in the future, but that's really where we're standing. So I set up a Class C address in here, and that gives me 255 computers over here, roughly. Do I have more than 250 machines in here? God, I hope not, because they would be really crowded in here. So we're now set up. We've got our Class C address. At home, you have that. Notice I can have 254 addresses, and we'll explain why that's not 256. But for most small businesses, that's really big enough. But it does get to be an issue when your business gets bigger. So, come back, mouse. So when our business gets bigger, we're going to have a little bit of an issue. So how does our computers get an address? All right, you can quit watching the fun videos now. It's like, oh, yeah, I should probably do that. So there's a couple of different ways we can give a computer an address. I could go around here and put an IP address and all the information on every machine, and we're going to do that to a couple of them to experiment later on, but that seems like a lot of work, doesn't it? And the other issue I have is I can never have two IP addresses that are the same. If I do, it's going to hiccup and yell at me and say, nope, you can't do that. It'd be like you having the same phone number as somebody else. Nobody would ever be able to communicate. So we use a system called DHCP in most cases. So DHCP says, I'm going to give you an address, and I've got a mechanism to do that. So when your computer logs into my network, it waves its hand and says, hey, I need an address over here. It doesn't say, hey, Macarena, at least. But it says, hey, I need an address. And so one of the things I can use as a really quick troubleshooting tool, if I get on a computer and it doesn't have internet, and I do an IP config, and I see that the IP address that it uses is this 169 address, and it starts with a 169, I go, aha, it's not able to contact a DHCP server. And so Windows machines, if they don't see a DHCP server or don't get a response back, because they're waving their arm like they just don't care, and after a few seconds it goes, nobody wants to give me an address, I'm going to set on my own. And it gets this private IP address that starts with 169. It's not particularly useful, but it gives me an idea that, hey, something happened and something's wrong. So we'll talk a lot more about DHCP, but I just want you to see, if you see that 169, that's what it is. It means, oops, something went wrong. I should go restart my router and see if suddenly I can get an IP address. So class A, B, and C can all be public-facing addresses. But we don't want every computer to be public facing. Do you want your Xbox to be exposed out on the internet? Do you want your computer? So we hide it behind those routers. And so to do that, we use an internal address for a private network. And so we burn off some special addresses, and we call them not routable. So even if they are outside facing, they're not routable. We can't use them to route things from one piece of the internet to the other. These only live behind our router. So internally here, everything that comes out of this lab looks like one IP address going back to the college. So the college can't tell who in here is surfing porn. Wait, before I say that, I can, but you can. But that, and I'll walk behind you. But the college can't see that. Your internet provider can't tell which computer behind that network of yours is doing something wrong and sending out data. And so we use 3 different addresses. So you guys use this address most of the time. That 192.168.0, so it's usually set up 0.1 or 1.0, and so you usually have that range. There's a Class B one with 172s, and honestly, it's not used a whole lot right now. Most places have went to the 10 range. So the 10 range is also a private IP address, but notice we have the ability to control all of that 10 range. So 10 dot nothing all the way to 10.255.255. So in theory, you could set up 16 million private IP addresses inside of there. And you go, well, okay, but and actually if you looked at our router, internally our college uses the 10 range. So internally our college uses this. So I set up a private network at 192. They have a network at 10 range, so I route into them, and then we route out to the public internet. So if you see an address that says 192.172.10, that means that it's not routable. Well, here's a quick question for you, and I think I closed it, maybe I didn't. So if you go to CMD again, remember I showed you that ping command really quickly, and the ping will show you what a website address is. So I pinged peru.edu. But I just said, wait a minute, 192 addresses aren't IP addresses, right? They're not usable out on the outside. But I pinged peru.edu, and I got a 192 address, didn't I? So in here, we're inside of that private network. Our router says that's really what Peru is internally. If I were doing this from my house, I get a completely different IP address. I get Peru's outside IP address. Right now we have the internal address. And that's part of that routing that I do in there with that DNS so that everything works inside of this lab. So things like email and other things that point back into our college don't go out onto the internet and then come back into the college. It just routes internally in our network. So there's an example of seeing that 192, and we'll see that quite a bit. So we need some more terms. And again, because we like to rhyme, I really think that some of the people that developed some of these were frustrated rappers. Because now we're going to have Nat and Pat. And it's either somebody naming their kids wrong or something. So network address translation. So we know that IPv4 doesn't have enough items. And so one of the ways we do that is we hide our IP addresses back behind here. So the college has one IP address, and then we have lots and lots and lots of internal ones. And so NAT says, I can translate from that internal back out to the external and then back as they go. PAT does the same thing. Remember those port addresses we talked about between 0 and 65,536? Does the same thing. So NAT and PAT really are the idea of it passes through our router and goes from an external network to an internal private network. So here's an example of what we're talking about. All of these computers in the internal private network, just like our lab, feed through a gateway, and that gateway says, here's my external true IP address, and then we have the internet. The PAT part then also says I have traffic from port 80 and I want to go from port 8000. So if I type in this socket address, it's going to route it to this particular machine at port 80 for web traffic. So right now I have 4 web servers set up, but I only have 1 outside IP address. How do I deal with that? And that's where I use that PAT. So notice it translates this port, port 8003, translates to port 80 on this particular machine. 8002 translates to port 80 on this machine. So it's a way we can conserve our resources and we create these rules. And again, I do the same thing. So if you see this guy floating around, and I can run the whole lab with my computer here, my iPad hooks onto the same wireless you guys do. And so I have to route it through all of our pieces here at our college to go from multiple networks, and it port translates a specific port back to a particular application on this computer using a single port. And so we'll look at that in a little more in detail. So, we talked about IPv4. 32-bit, not nearly enough addresses for us. So we've had IPv6 for many years. Now we really need to start moving forward on it. There's a couple of problems with IPv6. I can remember 192.168.180.1. I can't remember this. And so I think part of the reluctance, quite frankly, is network administrators don't want to have to try to memorize 2001:00:0B80:0000. Ah, great. Because these look pretty ugly. And if you notice, they're broken into blocks. Each block is 16 bits long. It's 128 bits altogether. That means there's 8 blocks. Oh, God. There's some shortcuts. And if it's a set of zeros in there, so if we have zeros, if all blocks contain zeros, we can put in double colons. But you only can use one set of double colons, because if you had 2 blocks, how would I know which one? So we can shortcut them a little bit, but they're pretty ugly in terms of what they look like. If we had written them with decimal, they would be even worse, because remember, this number of possible addresses is huge. And that's good, because we now use it for a lot of different things. So IPv6 is a little bit different. So IPv6, we want everybody to have an address that's outside. Now, I can still block, and I can do some other things with it, but by default, we would like to have everybody to have a unique IP address. So we don't have to do that translation anymore. And we have enough addresses that literally you could do that. So your phone, for example, probably has an IPv6. If you could run a program very similar to ipconfig on your phone, which you can actually dig into your settings and find out what the IP address of your phone is, and some of them are going to have multiple ID addresses, because how many of you hook your phone up to Wi-Fi as soon as you can? Yeah. Why pay for data if you don't have to? So we have some of these ideas. And IPv6, we're going to kind of skip over a little bit just because we don't use it a whole lot yet. I don't want to break everybody's mindset yet, but we're going to get to it. We're going to have some IPv6 in the future. We're going to talk about why it's really good. But I want to talk about types of addresses. So if I do a radio station puts out a message. Anybody with a radio can pick it up, right? But if I have a handheld walkie-talkie, only those people that have that same frequency can pick it up. So we need to think about a couple of different things here. Multicast means every node on a network. So if I use a multicast inside of my network, everybody inside of here gets that message. Anycast says, well, I need multiple locations, but I'm only going to send it to the nearest, closest place I can get to start with. So there's some differences in how we start sending out packets. And we don't want to take up our entire bandwidth, because one of the things you're going to find out is we have limits on our bandwidth, how big a pool we can put. So we want to be able to restrict and have some control over what kind of things we can send. So here's a visual graphic, and it might make a little more sense. So unicasting is that idea of I only send to one particular thing, which is the exact opposite of broadcasting. So broadcasting we send to everybody. Multicasting we send to a specific set of multiple addresses. And anycasting we have multiple recipients, but we only send it to the nearest recipient. So I know that's a little strange, and we'll figure out why we would use some of those things. So we need to look at what's included in this. So we're going to skip really quickly and look at IPv6 has all these different pieces. So that is an IPv6 address. So all those zeros and ones, so there's 128 of them all the way through there. Holy cow. And so we can say where it routes to, all these different pieces. Look at this. You shouldn't have a question about it, so we're going to pass that typically. So, skip one more. All right. We have to also look at a couple of other technology terms. And when we talk about security, we use these a little bit. And so one of the terms we're going to talk about is something called tunneling. Have you guys ever heard the word tunneling? And not just because you're going under a bridge. So tunneling means we have this great cloud we're going to go to. And in this case, we're showing a tunnel where we can use IPv4. This is what we're actually doing out on the internet now, is we can tunnel traffic from one network through to another. So we can tunnel IPv4 traffic through an IPv6 network or vice versa. So we can create these tunnels. More specifically, later on, we're going to talk about how we can tunnel traffic to keep it safe and encrypted so that you can have a network. So there's a lot of tools we're going to use in here. And so the event viewer. Has anybody used the event viewer before? When your computer crashes, this is the greatest tool in the world. So if I click the Windows button and I start typing event, it should pop up pretty quickly. And this is built into every Windows machine. There are similar tools in Ubuntu. If I can type event, it would help. So event viewer. So we'll pop it open slowly on this machine. Sometime. There it goes. So event viewer, Windows is recording a lot of information on this computer as it goes. And so as it does that, Window Viewer is also keeping track of any errors or anything that goes wrong. So it's a great troubleshooting technique. If you have a computer issue, your technician may look at this, you may look at it, and you may say, well, I need to go into the Windows logs, because Windows keeps all these logs, and I may see, are there any security issues? So in this case, it's not configured and turned on. Some of these are turned on by default, some are not. So notice already, this computer we just reset at the beginning of the school year. There's already 3,000 items in the application log alone. And I can look at it and I can say, well, what is this doing? There's a warning today at 11:17. And it says, oh, the user HP LaserJet P4105 preference in the group policy, blah, 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 blah. Do you see a LaserJet printer in here? No. And I can tell you where that's from because I never did take out the laser printer that used to sit in that corner out of the group policy. So it still tries to install this printer, And so every day it's going to have an error about that. Is it a big deal? No. Should I fix it? Yeah, but it's kind of like the leaky roof. I only think about it when I come in here and look at this, and I go, oh, yeah, I should have fixed that one again. So system will have some. So if there are errors, so notice here I've got a warning again. And you are going to see a lot of warnings. If you see red ones, that usually means you have some kind of an error. So the event viewer is a great way that we can dig through our computer and find out what's really going on. And so we can find errors. So if we have a network error, we'll dig in here and we'll start going, oh yeah, I bet I can find some information on it. So the event viewer is a great tool. And you can export these, you can modify them, you can create filters. So the event viewer, a great tool to start dealing with. We've talked about ping over and over again. So we've made you use it. And ping is really, it sends out a packet. It says, hey, are you alive? And if they respond, it sends a package back. Well, ping can also be used as a weapon. So remember all those options in there? And there was a command, the -T. And the T said, I'm going to keep pinging forever. Well, one computer sending out a ping to my web server isn't really bad, but it uses up a connection. Does a web server have unlimited connections to the internet? No. Does it have unlimited pipes into the internet? No. And so if I set it up where 32 computers were all pinging, could I shut down a web server? Probably not 32. But if I somehow had control of 10,000 computers on a botnet, and all I did was I had them send pings all day long to a web server, could I shut a web server down? Yeah. We really could. So ping is one of the tools we use, and it's a really quick one. So if I think, oh my goodness, the web server in there doesn't seem to be working, I can send a ping to it, and I know the IP address now, so I can go, I'm going to ping that router or that web server or my switch or other devices, and I can see if they respond. If they don't respond and I know that they're supposed to, I can go, ooh, there's a problem. So the other thing that ping does that's really, really neat is it shows us what if I ping Google, it tells me what that actual IP address is. So you can ping your loopback to see if, for example, your TCP stack is running on your computer. And notice, here's that -T. So here this would run continually. So if I could get a hold of 10,000 computers, I could take down Peru's website. I wouldn't want to, but we could. So if you're on an IPv6, you can do ping 6 to ping directly over an IPv6 network. So there's tools available for both, does the same thing. And again, remembering that gets to be the hardest part. So we also looked at the ipconfig. Now, I haven't showed you everything ipconfig can do yet. And so I'm going to have you guys do something that I can't do on this one. And one of the most powerful things it can do, it can show me all kinds of information, right? That IPv6 or ipconfig all will show me my router, my DNS entries, all these fun things. It actually shows me what servers I'm getting my routing information from. But I'm going to show you another one here. So I can't drop it because I'll lose my connection to the web. But take your computer and type ipconfig, /release. And I'm not going to hit enter. But when I release, what it does is it takes all of those connections that you've had with DHCP and drops them and says, nope, you're no longer connected. Oh, how do I get them back? So now if I type the same thing, I type ipconfig/renew, then it will go out and it sends a message and says, hey, I need an IP address. Somebody give me one. and now it'll get an IP address. So a lot of times I will use this to make sure that my DHCP server is working. So do I get a new address? Do I get an address at all? So ipconfig can do a lot of fun things. The other one that's really important is this bottom one down here, the flush DNS. So if it's got some bad information on your local computer about DNS information, something seems really weird, it's a really good troubleshooting step to do the flush DNS. So as a side note, there's an extra credit assignment with your installing Ubuntu if you can figure out how to do this in Linux at the command line. So Linux, being a little different operating system, has similar things. And I will tell you the first step to that is that there is something similar to ipconfig. It's called ifconfig. So ipconfig. We're going to get all kinds of nerdy tools. So I use ipconfig. I use ping all of the time. I probably do that once a day. And not just because I want to hang out nerdy. So ifconfig, very, very similar. So some of the similar commands. ifconfig-a is kind of similar to the ipconfig/all. You can also put an interface up or down, so similar to the release. So some of you may have Macs. Anybody in here got a Mac? So your Macs actually can run, because on the back end, it actually runs a Unix operating system. So we have reached the nerdiest land of all. Something called namespace lookup. NSLookup. So NSLookup lets us contact that DNS server directly if we want to. And so it does a couple of things. So we can do multiples. We can do reverse DNS. So if I know an IP address, maybe I want to see what the DNS entry is for that. So maybe I'm like, I don't know what that server's name is, but I sure know its IP address. How can I find that and work backwards? So NSLookup. So here we show an example. So here we're looking up NSLookup www.cengage.com. And it's going to say, well, here's a server, here's a non-authoritative resource, here's an address, and we can see what it looks like. So we'll play around with that, probably not today. We have a little bit more to go over. I do use this when I have DNS issues. You can also do commands with it, which is a little more frightening. So if I already have a server set up for DNS, but I want to change it, I can actually change it inside of here at a command line. So DNS lookup we'll get to, but it's a little more complicated. So one of the things, hopefully when you're trying to search for that extra credit and those bonus points, is you can find some of that. So we'll use NSLookup when we get a little further along dealing with our server and playing with that. So quick things. What do I need to remember? What is an IP4 address? Because that's the one you're going to encounter for the next couple of years more than likely. What does it look like? How long is it? 32 bits? How long is an IPv6 address? Why do I need IPv6? What's a Class A address? What's a Class B? What's a Class C? So you're going to see those over and over again. And now that we've kind of got that idea, when you start looking around, you're going to go, oh yeah, at my house I get XYZ. So it might be interesting to look at what your external IP address is. And so let me give you one more quick tool. So this one's a website. So because I don't know, if I just type in here really quickly into Google, what is my IP? It's going to tell me my outside IP address. So if I'm at my house, I can see what my outside IP address is. And so you're going to end up with a mapping. So maybe you have at your house an 11. That's your external, and inside you might have an internal address group like this. And so we have that mapping between the two of those addresses. So, all right, so back to the router. If you see our router, and it's a little hard to see on the screen, so I apologize. It's a little fuzzy. So I have a rule enabled. So if I can get to see, we're putting in rules, and we can look at some of these rules. And so in here, we have some NAT rules, and we have some port forwarding. And I really want to look at, let me go back here for a second. So I said we used a particular device. So on port 7019, I'm looking for both protocols. And those protocols, remember that TCP and UDP. And I'm going to send them to, so anything hits the outside of my router and asks for that port 7019, it says I'm going to forward that then to 192.168.180.101. That is part of how I get this to go through the wireless network. Now, there's some more routing rules external to this router, but they hit this router. So it's in this big pool. This sends out a signal and says, hey, I'm sending traffic on port 7019. I don't tell it what IP address it needs to go to because it doesn't know 192.168.180.101. If I tried to do that, it wouldn't go anywhere because that network address only exists internally here. And this is not on this internal network. So it feeds through, and as soon as this router says, hey, I've got traffic for this port, it then feeds it to the computer so you guys could see this. So if I wanted to hit a record button, so now I'm sending in a signal into that computer back and forth. I can draw on the screen. I can do all kinds of different things, record. And it does it through that idea of port forwarding. That idea of we're taking a specific type of implement and we're sending it through. So we could do the same thing with web servers. So this is what it looks like. That's a pretty simple rule that we have in there. So this router is a little different than what you have at your house, and we'll look at some examples of those. I'm going to close that out. This router in here, this one was about $300, and it's really kind of a bargain at $300 for what it does. The router at your house, what do you guys spend for a wireless router and the wired thing? $50, $100 maybe? Some of you may have gotten a gaming router and got talked into spending a couple $100. But the reality, and we've tried them, they don't handle the amount of data we send through here. At your house, you don't have 35 computers hooked up to one router. Well, you might. No, I don't. Some people might. But this is able to handle that amount of traffic. But on the other hand, is this router big enough to handle the traffic for the entire college? No. And so the router they use is probably around $5,000 to $10,000 at least. And it handles our campus traffic, but is it big enough to handle Verizon's traffic at the Verizon data center? No. So there's levels and different types of these kinds of things. All right, so let's talk about some assignments and some pieces that you hopefully have gotten done. Close out of there, come over here. All right, so there's really 2 weeks worth of assignments due on Sunday night, right? But do we have school on Monday? No. So Dolores begged and pleaded and said, maybe we should move that due date one more day forward. So we'll leave it up to the on-campus class to vote on that. Would you guys like to slide that date one more day forward to the end of Monday night? All right, I will send out an announcement, but let's talk about what things all need to be done for this end of the due date. So everybody now should have their book and lab connections, right? And so I'm going to send out lab connections notices. I'm going to try to patch up and make sure everybody's gotten lab connections and has started on it. So if you start seeing cranky emails about, hey, how come you haven't got this done, or vice versa, I will try to let you know. So who in here doesn't have lab connections yet? Just so I know who doesn't have. You guys all have lab connections? Oh, you have it, but you haven't put it in there, Trevor. All right. I know how to motivate you. I will talk to your other half, and she will get you motivated. So if you haven't got lab connections, get it. All right. If you haven't bought the book, you need the book for this class. It's fairly inexpensive if you rent it or if you buy the ebook version. I think the ebook version is only like $26. So you will need it to pass some of these items. So I'm going to look at week 1 first here, and to make sure that we're all on track on the assignments. So week 1 has a quiz. There is an assignment where we're going to set up something called VirtualBox. We're creating virtual machines. And so I've had a lot of questions about that. Why do I do that? If I already have Windows 10, why do I need to set up Windows 10 again? What you're doing is creating up a operating system in a bubble. So we're going to use it as a sandbox. So if you screw something up really bad, or you get infected, or anything else in some of the stuff we do, I reset it and I turn it off. And I restart over again. So it gives us that safety valve. It also lets us try multiple operating systems. So if I have a Macintosh computer, I may want to run a Windows machine and try to see what it looks like. It lets me do that. It lets me run Windows 7, Windows XP, Windows 10, Windows 8.1, Solaris, Unix, different versions, and I can run all of those inside of that bubble, that safety net. So if I'm a web designer, I will have multiple copies in a VirtualBox or something similar so that I can try out my web page and make sure it works in multiple versions. It's a great tool for that. Or if I'm a programmer, if I just want to see what the other half of the world is living like, I can also do that. In theory, we could even run a Macintosh operating system inside of that VirtualBox environment. But that one is a little harder. Apple doesn't like the idea of virtualization, or doesn't want to sell you that idea. They don't want to sully themselves by running on a Windows 10 machine. But the reality is, if you have a new MacBook computer and you have a new Windows computer, the hardware is pretty much identical. So in some cases, they call them Hackintoshes. People have managed to get it to run. So if I have a Mac, I can run about anything. If I have an Ubuntu or something running, I can do that. So this assignment, there are lots of resources for. So you need a couple of things. If you haven't done this already, it will take a little bit of time for some downloads. You have to install VirtualBox, and we'll show you what that looks like. You have to download an installation file for the operating system you're going to run. So the easiest place to get that is our Microsoft Imagine store. So you can get Windows 10, Windows 8, Windows XP. You can get Windows Server if you really want to play with a Windows Server version and experiment with it. And you can get that all at Microsoft Imagine. And so under course documents and under video links, there's a ton of information and videos going through how to do those. One of the strange keys to this, though, is some people have gotten bit by not watching the video and seeing how to create a local account. Windows 10 wants to tie you to a Microsoft account. You do not need to do that. And in fact, I encourage you not to do that. And I show you a method in the video on how to avoid that unpleasantness. And you're saying, hey, I'm going to create this on a local administration and I'm going to create a local account. So there's videos in there that will go through all of that. So a couple of pieces. We have all this. There's a link to Microsoft Imagine. You can also find it on our website if you find either, I believe it's on Ms. Perriott's website and mine, both as a link. If you get in there and have a problem in there, and you email the administrator of that, it actually goes to me. So if you have a problem, email me directly, because then it doesn't go through the hoops of not being able to forward and several other things. So you need to download that file. That file that you're going to download is called an ISO, a .iso. It is a copy of, if you had bought that in a disk from the store, it's a copy of that. Windows 10 can open it. Don't do that. Just let it set as one big file for now. That makes life a little easier. So that's our quick recap of the things you need for this. You do, and it's actually, I was going to head there right there. It's actually in the discussion. No, that one's in the assignment. All I need for that is a screenshot showing your screen with VirtualBox and Windows 10 up and running. So I just want to make sure that it actually runs. So, great. You could go on the internet, fake a screenshot. It's not going to help you in the future. So make sure you actually do that. We also want to show you what virtualization is, because most of the world is moving to virtualization on servers. No longer is it one piece of hardware and one operating system. It's one piece of hardware, and there may be multiple operating systems all on that server. So, and we're going to get to the point we're going to talk about that and look at that a little more in depth. So I want you to get comfortable with the idea of virtualization. If you're really paranoid, you could do everything inside one of those VirtualBox shells, and that way if your computer gets hacked, you download something you shouldn't have, you're surfing websites you shouldn't be. Not sure why I'm looking at you guys over there. You can just restart that or go back to an image of it. So some companies actually do their entire work within those VirtualBox shells or something similar. So let's go quickly to the discussion board, and we'll go over some of the items in there. So discussion board. Make sure you've introduced yourself. Most of you have. 50 out of the 60 students have. There is an instructor's corner in here. If you have the answer to a question somebody has, feel free to look at an answer. You might even subscribe to it. And if you haven't ever subscribed to a format, up here notice there's a unsubscribe or a subscribe. So week one. Week one says there's an assignment in the back of the book, project 1.2, 1.3, or 1.4. So you have a couple of choices about things to do, and what I'm asking you to do is either do a PowerPoint, you can do a Prezi, some way you're going to show back that information that you found. You do not need to comment back on another student on that, and I know you guys are in class, but it's another way we can show you, and you guys can all look at each other's work, and you might find something interesting. Quite frankly, with there being 60 people going to hopefully post in there for grades, I don't expect you're going to have a chance to look at all of them, but look at a few of them. Go in and look and see what other people have discovered. So one of the keys to these discussion boards in this class, when we use them, go in and have a very descriptive title. So say something, not just week 2 discussion board. So say, hey, I found this, blah, blah, blah. Or make it descriptive enough that we know what it is. Week 2, and I'll jump to week 2 to start with here, is week 2, you're also using VirtualBox. And there's instructions on project 2-1, but it's pretty simple, and I know some of you have done it, is you're going to now install Ubuntu. Oh. So now you guys are going to get a Linux operating system that we can experiment with and look at in here. And so when you start up VirtualBox, you're going to have multiple operating system possibilities. So you need to install Ubuntu. And again, what I need from that is this time we're going to do something, and I'm doing some experimenting to see how well some of these tools work. So this time you guys are going to use something like Padlet. Have you guys used Padlet before? Nobody in here has? Great. So it'll be a learning experience. It's pretty easy to use, and you're just going to really quick create what's called a Padlet with a couple of screenshots showing, hey, I got it installed. There is an extra credit bonus potential in here. And so that potential is you need to figure out a way and show me how to do it and tell me how to do it in your Padlet link to flush DNS. So the same tool we used in Microsoft, is there something equivalent, and how would I do that if I had Ubuntu? So those are the two discussion boards you need to post to. And again, neither one of those do you need to respond to other students. We do not want to force you to have any interaction at this point. So let's look at week 2 really quickly. So week 2 says, all right, oh man, we got to install something else. It says install and use Wireshark. Now, for those of you that are on the Macs, especially, there is a version of Wireshark for a Mac. It looks significantly different. If I were doing it and I had a Mac and all the money to go buy one, I would probably install Wireshark inside of my Windows 10 environment. Does that make sense? You run Windows 10, you can install software. You really have a version of Windows 10 running, and I would install it inside of there. Otherwise, you can install it locally on your computer. And so, again, there is a video, if I go back to course documents, on how to install it. It is version 5.01, and this is 5.1 is the latest one out there, I think it is, or something. Somewhere there's a little bit of a difference because they keep coming out with new versions. So there is a quiz for Chapter 2. This just links back to that discussion board about how to install Ubuntu that you have to do. And then you have a couple of things. I have the fail video that just has the cranky IP addresses. And then Monday's class video is already in there. So you can certainly look at that if you have some need to. So where are we at? Oh, I'm just on time. All right, so if I can have your attention up here, what I would like to do is really quickly run through installing Wireshark. I will not run through the entire assignment. However, again, if you look under course documents, there happens to be a couple of ways and things that I created previously. Course documents. So, course documents. There are a couple of things. So, you'll see down here there's even a video capture of using a command line FTP, and you're like, oh, where was that? I'll have to see that in a little bit. And most of the videos I've now migrated up into here. So, installing VirtualBox, install Wireshark, Wireshark Case Project 4.2. So I lead you literally through there. But I want to go through how to install Wireshark really quickly. The other piece of that is it updates Wireshark on most of these computers in the lab. Great. I'm using you guys like lab techs. So if you will work with me, we will do this really quickly, and you'll see what Wireshark is going to look like. So first thing we need to do is figure out, where do we get Wireshark? Does anybody know? Oh, Wireshark.org. So this is a tool that we're going to use. All right. So I'd like to go to SharkFest. It's in Europe. Is anybody here rich and want to take me to Europe? Huh. I have seen the video of the shark inside the diver's cage. Not going to do that. However, this is just a tool. Sharks are friendly and fun and nice, and they're not going to cause us any issues, right? Hopefully. So Wireshark is a community-developed product. It's open-source software. In other words, we don't pay for it, and yet it's one of the most powerful tools you're going to find out there. Great. But what people will do is hire services that use Wireshark. So let's take a look at Wireshark really quickly. And if we go up here and we say, well, I want to get acquainted, there's all kinds of things about how do I start, how do I begin, but I want to click on the download to start. There's a lot of information on their website. And so I click on Download Wireshark, and notice that we have a lot of different versions. So again, if you're going to try it on your Mac, here's a version. I'm going to click the 64-bit installer, and it will take a few seconds to download at our internet connection. Or maybe more than a few. If I could have a fuzzier monitor up there. So the more of you download, remember we have one pipe out of this lab, and in fact we'll start playing with that fairly quickly. The more of you are on there, it's going to start significantly slowing down. So 16 seconds left again. So let's download and grab Wireshark, please. I'm going to write a password. So if you're online and you're not in an Active Directory, you don't need to worry about that. But here, we're under an Active Directory structure. And so I created an account we use in here for you guys. So there's an account called Lab User, and it uses the same password to log in as the normal computer account. So we set those up temporarily. It works really great. So now hopefully it's downloaded. And I'm going to double click it to run this application. So when you get this user account control, that's where I have to use that account. So I type in lab user. And if I can type it correctly, Peru 2017. And so in this case, it's going to say there's an existing version on your computer. And I'm going to say, yes, I do want to uninstall it first, and I want to install the latest version. So I'm going to click Next. Reviewed the agreement. Yes, I do want to use it. Click Next. I'm going to leave all of those default. The other thing that I will run into, if I have not installed this software before, I'm going to get a window that says, do you want to install WinPCAP? I need WinPCAP. It's a utility that's actually packet capture. Windows packet capture, WinPCAP. That's what grabs the data for me behind the scenes. So it's another program, but it's installed with Wireshark. So right now I have 4.1.3. Do I want to install 4.1.3? Don't need to change that, so I'm going to not select it. So in the lab, you shouldn't have to select that. On your own machine, you'll probably need to allow it. USB PCAP, if you connect with a USB interface, so if you have an external wireless adapter, you probably need this. For our purposes here, we don't. So I'm not going to install USB PCAP. And when I install this, it's going to take a little bit to go through. It's going to extract. So this is actually packet capture software. We can see and get data from what's going on over the network. We're going to get to see those zeros and ones that are being transmitted. So when you get done, it will probably say you need to reboot. Most of you have faster computers than the one I have up front, which is always interesting. But I'm going to click Next. All right, I'm going to not reboot right at this minute because I think it'll work for me, hopefully. So now I've installed Wireshark. That wasn't really tough, was it? Used all the defaults. Life was pretty good. There are some interesting versions that are coming out. So the Windows Portable version, you can actually run off a flash drive and don't even need to install it. But I have not had really great luck running it, quite frankly. So I'm going to start Wireshark now. And so I'm going to click my Windows icon and type Wire. And it appears as a desktop app. It probably also set one on your desktop. and somewhere it's starting, maybe. There it goes. All right. So, Wireshark now shows me both of my network connections. And all of you will have at least two. In the lab, notice I'm showing both of them seem to have activity. And so what I am seeing, because I've got VirtualBox open, one of these is a virtual connection inside of there. So the other one you're going to see, so if you're on a laptop, or a lot of the desktops have wireless cards in them, you will see multiple connections. Well, what I can do, and notice it's making this little graph, it shows me which one has traffic. So if I have a laptop and I have a wired connection and a wireless, and I don't have anything connected to that wired connection, it's not going to show any traffic. So I don't need to necessarily grab packets with it. And in fact, it's getting a little better about showing us information. So I can hover over it, and it will show me some information. If I can get it to pop up. So notice this one says, this address is 192.168.56.1. 56.1. I don't remember seeing that because I was pretty sure my lab was 180.1. But that is that virtual address that VirtualBox is giving us. So I don't really want to click on that one at this point. I'm going to look at the other address. And so the other address should tell me that it's the 101. So it says, 192.168.180.101. And so that's the one I'm going to highlight. And now I see all of those interfaces. If I simply click on the little shark fin, it's capturing traffic already. And so in just this little bit, in just that little bitty bit, it's captured traffic. And that's what Wireshark does. This is all of the pieces of data going across our computer. So, in not very many seconds, you can scroll down and I can actually see how many packets. Because notice that it gives me a number. So, I'm trying to be two places here with my mouse. If I click upside down, it will reorder that. So I can click up. So in that amount of time, I got almost 1,000 packets, or a little over 1,000 packets in that amount of time. Because we break everything up, it's sending me that data really, really, really quickly. So some of these we're going to recognize and start to make some sense. And some of them as we go through are going to start to make more sense. So this piece right down here on the bottom left, this is actually what that packet looks like. Now, it's showing it to you in hexadecimal, but remember, it's really binary data. So it's actually got a form of a hex editor. Because it's really handy, because we know that these are generally broken up into groups of bytes, B-Y-T-E. So each one of those numbers is one of the bytes that's being transmitted. And so sometimes over here, you can actually see information. Sometimes weird things will pop up. You may even see passwords. So you'll see that you can organize these. One of the keys is by any type of header up here. So where it's going, where it's coming from, what type. So source is where it's headed to, or source is where it's coming, destination is where it's going. The protocol, or the language of it, you may see a length, and that length is in bytes. And you'll see additional information if it has any. So notice this right here. Notice it's got that info where it says 7019. Did we see 7019 earlier somewhere? Did we call that a port somewhere? And it's the port on this guy, on my Deseri. And it's actually showing you all that traffic right there that's going across. But what's interesting, it actually says here's a link. So if I look at any of those, it's got a link. And then it's got a link over in the column header. Why would those be different? So it shows me two different links over here. So I see one that says every one of those packets is 1,374, but yet when I look at the packet capture, it says they're 1,440. That's due to that encapsulation. So the original packet was 1,374 bytes, and now it's encapsulated. It's got extra stuff added to it, and that's one of the things you're going to start seeing in here. So in your book, it leads you through this pretty quickly, and has you experiment with it. So what do I need for this assignment? I don't need a screenshot of every individual step. 5 or 6 screenshots are enough to tell me that you've went through all the pieces. So you can hit the red stop button anytime. So the red stop. The screenshot? No, I don't care about the install. The install is so easy. There are step-by-step instructions in the book about using Wireshark, and I need a couple of screenshots as you go through that. Sorry, I wasn't catching what you were. But there is a ton of traffic out there, and we can find out a lot of information about a particular computer. And in fact, we're going to show you how to take our switch and feed all of the traffic for every computer into one version of Wireshark. So if I could do that at a company, could I get a lot of details and information on that company? Because internally, is all of our traffic encrypted? No. So how many times do you think passwords get sent unencrypted across the network? A lot. So we're going to set up some tools in here, and we're going to take a look at it from that side. So right now, we got to get you some of the base pieces. We got to figure out, well, what is Wireshark? Get familiar with kind of how it operates. Be able to grab capture packets. So if we're able to do this on a wireless network, you may be able to get enough packets and enough data to break that wireless code. Ooh, that's probably not good. So this is a great tool for troubleshooting, but this is also one of the most widely used tools for hackers. So it's one of those coins. So, all right, so we have a list of everything we need for next Monday night to be done, right? And I'm going to hound you and send some emails. You need to make sure you have bought Lab Connections. You have the book. Some of these assignments in this class are going to take you some time to do. They're not impossible, and I try to give you enough tools, videos, assistance, that you can get through that. So what I don't want is if I say, hey, go back and watch the video, you skipped a step, to have anybody's feelings get hurt, okay? Because sometimes we all get, oh, I can't believe I missed that. But we want you to learn how to do these things. We want you to leave these classes being the best nerds you can be, where you can pip up that command line window and all your friends will go, ooh, what are you doing? And then you can point out all the flaws when you go see movies about what they're doing also. All right, so let's get out of here. Have a great Labor Day weekend. I will change that date to Monday I don't know the date itself, but I'll have to look it up. Is it the 4th? So we'll flip that from the 3rd to the 4th. So do not wait until that Monday to start doing all this, because you'll probably be sad that day.